This video will make an attempt to explain the difference from our star, and the orbital satellites accompanying it. It is our belief that there is much confusion about the brown dwarf and its satellites. Many believe the dwarf itself will be passing through our solar system. This will not be the case. Since we believe we are in a binary system, understanding how binary stars orbit each other must be applied here. If both our Sun and its partner were of equal mass, we know then they would orbit each other in an equal circle. However, when binary stars are not equal size, the smaller star must swing around in a wider orbit around the other star, in this case our Sun, which barely seems to orbit at all. Since our Sun has 10 times more mass than this incoming star, the center of mass between them shifts closer to our Sun. To strengthen this binary theory, we look closely at the comets. If our Sun was alone, then the comets in the Oort cloud would have predictable and normal orbits. They would be regular in their arrival time. But they're not. Without any gravitational interference, these comets would spread out evenly across the sky. But when we look out in the sky, we can see where these comets are coming from. They are tending to concentrate in a region of the night sky. We think this is because they are being influenced by the gravitational perturbation of this Kuiper belt object. When we first spotted this star in the constellation of Aquarius during 2013, we've been watching its progress move ever so slowly toward us. By this March 23, 2016, it should be at the orbit of Neptune, our furthest gas giant. In this next image we will show you what we believe is the outcome as the star swings around our Sun. In this demonstration you can see the star with its orbital moons. Notice how the star remains outside the solar system. At the same time, please take notice of the moons as their AU distance from the star reaches well into the solar system. The first strike is between Jupiter and Mars. This is where the asteroid belt becomes disturbed. As you follow the orbit, one moon moves between the Earth and the Sun. This is eastern elongation. This will deliver a very strong solar shot. It is extremely important to know just where the Earth will be when this moon rounds the Sun. These are the possible positions for an eastern elongation pass. Number 1 would be okay, but the Earth would orbit into the remains of a strong solar shot. Number 2 is a position that would put the Earth right in the path of the solar shot. The potential for a large loss of life is highly likely. While number 3 would be the best case scenario. At this time it's almost impossible to say just where the Earth will be. This is why we don't like to give timelines. The Earth's position during the orbital pass is extremely important. Much depends on getting this right. When using images on the web, you must understand that some webcams and all sky images are controlled by the government. They are showing you what they want you to see. As soon as the weather here becomes more tolerable, we will be once again be hitting the trails. We are going to be streaming the sky live. We hope you join us. The link for live view is on the main page of the website. We have also added a calendar. This is where we will be scheduling our events, so check it often. Thank you.